The fangs cannot retract, they cannot fold, they physically prevent the mouth from closing, and the fish eats anyway. Chauliodon macuni, the Pacific viperfish. Pulled from 1,500 meters of cold Pacific dark, it arrives looking like something that should not work. The body is silver, the length of a human forearm. The fangs are longer than the head itself. Bruce Robison at the Monterey Bay Aquarium Research Institute put it plainly in the Journal of Experimental Marine Biology and Ecology in 2004. The teeth are so long that they would pierce the fish's own brain if they could close their mouths completely. Read that again. The animal's own anatomy would kill it if the geometry worked differently. It doesn't work differently. That is the point. Peter Herring, writing for Oxford University Press in 2002, measured the jaw depression angle. The lower jaw can be depressed to an angle of more than 90 degrees from the body axis. More than a right angle, the mouth doesn't open. It collapses downward, away from the skull, like a trapdoor falling open in both directions at once. The fangs themselves have no enamel, no protective coating, solid dentine, continuous growth, never stopping. They curve outward and downward past the jawline, tips nearly reaching the belly. There is no socket waiting to receive them, no groove, no sheath. They simply extend, permanent, fixed, exposed. In August 2004, the Embari Rov Tiburon descended off the California coast and captured extended video of viperfish hunting at depth. The footage showed the animal motionless in the black water, waiting. A creature with no ability to close its mouth, holding still in absolute dark. No researcher has captured a complete feeding sequence, detection to swallow, start to finish. It has never been filmed, only fragments. Something happens inside that skull. Something mechanical, something that should not exist in a fish. By the end of this video, the specific moving part responsible will be explained in full, named, measured, and documented. Keep following the anatomy. So the obvious answer is, the fangs are just for show, intimidation, decoration, case closed. Except, nobody who ran the measurements believed that for long. Vladimir Chernavin did the geometry in 1953. He published a morphological study, precise and methodical and obsessive, measuring the arc traced by a viperfish fang against the maximum angle the jaw hinge could physically achieve. The numbers did not cooperate. The fang arc exceeded the jaw's maximum gape, not by a little. The math produced an overlap zone, a region where, no matter how wide the mouth opened, the fang tips still crossed the plane of the upper jaw. The fish literally cannot open wide enough to clear its own teeth. Brute force was the second theory. Maybe the jaw just cranks wide enough to let the fangs swing past. Maybe the gape angle measurements were conservative. They were not conservative. Modern morphological analysis confirmed Chernavin's core finding. The geometry is not close. It is not a borderline case requiring better instruments. The fang arc and the jaw hinge angle are incompatible. Full stop. So the fangs are not decoration, and the jaw cannot simply open wider. Two explanations, two failures. Then the photophores entered the picture. The mystery doubled. Along the viperfish's ventral surface runs a row of small, evenly spaced bioluminescent organs. Peter Herring mapped photophore distribution across mesopelagic fish families, and the pattern in viperfish is striking. Those photophores face downward, not upward toward prey, down into darker water. Every lure logic model predicts light pointing toward prey. The anglerfish points its lure upward, toward shallower water where prey might see it from below. The viperfish points its lights in the opposite direction entirely. Edith Widder's deep-sea bioluminescence research documented how light placement determines hunting strategy. By that framework, the viperfish's photophore row is pointing the wrong way. The geometry is impossible. The light is aimed at nothing, which means the standard explanations, brute force and lure logic, don't account for what this animal actually does. Something structural is happening inside the viperfish that nobody had measured yet. Here is the answer nobody wanted to wait for. The skull moves. Not the jaw, not the teeth. The skull itself, the neurocranium, the case that holds the brain, rotates upward on a flexible joint, physically lifting away from the vertebral column. That gap, that clearance created by a rotating brain case, is exactly what the fangs need to swing inward. Vladimir Chernovin measured and documented this mechanism in 1953, cranial kinesis. The brain moves so the fish can eat. This is not metaphor. The neurocranium depresses relative to the spine. Modern CT scan analysis confirmed what Chernovin described by hand. A trapdoor built from bone and cartilage, opening in milliseconds, resetting before the prey stops moving. Remember the problem from the beginning. Fangs too long to close, a mouth that should be structurally impossible. The answer was never in the teeth. It was one joint higher. The architecture of the skull itself was the solution the whole time. But the photophores were still unexplained, and here is where it gets stranger. Those belly lights do not lure prey downward. They match the faint blue light filtering from the surface above, calibrated to the ambient glow of the mesopelagic zone. A predator looking up from below sees no dark silhouette, just ocean light. The viperfish disappears, counterintelligence and active lure in a single organ row, running the length of the body. Edith Widder, documenting bioluminescent behavior in 2005 using the Eye in the Sea camera system, described this class of photophore function as counter-illumination, camouflage through light production, not darkness. One fish, one hinged skull, one row of lights that erase its own shadow. Evolution solved 3 problems with 2 structures, and science took until the 21st century to read the full blueprint. The Pacific viperfish is still down there, right now, migrating 1,500 meters upward in the dark, jaw open, brain shifting, lights on. If you found this fascinating, subscribe. We investigate strange, real creatures like this every single day.